This question is about the isotopes of chromium. Give the meaning of the term relative atomic mass. So there's many different ways of giving this definition. The one that I prefer is the weighted average mass. So we're weighting to do with the percentage abundance of each isotope. So the weighted average mass of all the isotopes, in this case of chromium, relative, and this is the bit where a lot of students lose some of their marks, to 1/12 the mass of one atom. All these bits, 1/12 mass, one atom of carbon-12, they're all important. A sample of chromium containing the isotopes 50, 52, 53 has a relative atomic mass of 52.1. The sample contains 86.1% 52. Calculate the percentage of the other two isotopes. So I'm just going to sort of lay this out in a more traditional format. We've got the 50 isotope, the 52 and the 53. These are their masses and then their abundances. So we know it says we've got 86.1% of this. So I'm going to say that we've got X% of the 50. What we'll know then is that the 53 must be whatever is left if I do 100 minus 86.1. So there's 13.9 in total for 50 and 53. So there'll be 13.9 minus X. So that if I added all three of these up, X, add 86.1, add 13.9 minus X, I will get to exactly 100. Then I'm going to say that our calculation goes that the AR, so in this case 52.1, is equal to mass times abundance, so 50X plus 52 times 86.1 plus 53 times 13.9 minus X, all over total abundance, which in this case is 100. And I'm going to do some rearrangement with the algebra. So I'm going to multiply by 100, and then I'm going to start multiplying out the brackets. 52 times 86.1, so 4,477.2. Oops. That one shouldn't be an equal, should it? That should be a plus. And then we've got 53 times 13.9. 736.7, and let's not remember we've got 53 times minus X, so minus 53X. Then I'm going to take over the numbers, so 5210 minus 4477.2 minus 736.7 equals 50X minus 53X. So I'm getting minus 3.9 equals minus 3x. So x equals 1.3. So if x equals 1.3, then the percentage of chromium is 50 is chromium 1.3. Then 13.9 minus 1.3 gives me the 53. And that is 12.6. State in terms of the number of fundamental particles, one similarity and one difference between atoms of 50 chromium and 53. Remembering these are isotopes, they will have the same number of protons. The fundamental particles are the protons, the neutrons and the electrons. Same number of protons between both isotopes. It's really a secret way of asking us the definition. And the difference is that they'll have a different number of neutrons. Chromium 53 has 3 more neutrons than chromium 50. The sample of chromium is analysed in a time-of-flight mass spectrometer. Give 2 reasons why it is necessary to ionise isotopes of chromium before they can be analysed. Well, the ionisation is to make them charged, and they need to be charged so they can be accelerated by the electric field. They also need to be charged so they can be detected and create a current. A 53 chromium plus ion travels along a flight tube with a length of 1.25 metres. The ion has constant kinetic energy of 1.102 times 10 to the minus 13 joules. And they've given us the equation for kinetic energy, half mv squared, or mv squared divided by 2. Calculate the time. So what we're having to remember here is that velocity is distance divided by time. So time is distance divided by velocity. For the 53 Cr plus ion to travel down the flight tube to reach the detector, and it's given us the Avogadro's constant. That is because we need to find the mass of one ion, and 53 is the mass of 1 mole in grams, and we need the mass of one ion in kilograms. So I'm going to turn grams into kilograms and then divide by how many are in a mole in order to find the mass of one. So I'm going to do that first, get the mass of one ion. So on your calculator, 53 times 10 to the minus 3 divided by Avogadro's constant, and you're getting 8.80 times 10 to the minus 26 kilograms. I'm going to rearrange for V because to get time I need to get velocity. So V would be 2 times kinetic energy divided by mass, all square rooted because V squared was in our equation. So we're going to do the square root of 2 times the kinetic energy, 1.102 times 10 to the minus 13 divided by the mass that I've just calculated. So I'm going to put all that in my calculator, square root sign, then a fraction, and type in the numbers. And that is coming out as 1582480, or 1.58 times 10 to the 6 meters per second. And then remember that we said that t equals distance divided by velocity. So it's what we're trying to find. So it was 1.25 meters divided by the number that we've just calculated. So on your calculator you can figure that out, 7.90 times 10 to the minus 7 seconds.